We will begin our second unit by going into the different types of addition and subtraction. In the next lesson, we'll focus more on multiplication and division. But in this lesson, we're going to talk about the different models of addition, the different models of subtraction, doing mental addition and subtraction, and some estimation within this lesson. I really wish, we had a lot more time to spend on every concept. I really feel like, this course is something that I could spread out over much more time, because we're trying to go into all the different math, K through 8, and show you how to teach it, in one semester. Well, actually, we do part of it in 1351, but all of the numeration, the algorithms, and things like that, we do in 1350. And it really is a challenge to get that done, because I wish we did have more time to go into more depth on every concept. But the good thing is, when you're a teacher, you're going to dive into that, really tear it apart when you're the actual teacher. And what we'll do in this class will give you a good overview and a good base of where to start. So for the addition models, which is what we'll start with, we're just going to talk about first the number systems that we're going to focus on, because we're going to focus on addition and subtraction of whole numbers. Later in the semester, we'll bring in integers and look at some negative numbers and the addition of subtraction of that, and even move into some rational numbers. But in this particular lesson, we're just focusing on the addition and subtraction of whole numbers, which starts at a very, very early age. The natural numbers we know start with 1. The whole numbers add in the 0. And our first definition for today is closure. We just finished in Unit 1 talking about sets, and we're going to carry that on a little bit today. So a set is said to be closed under the operation of addition if, by adding any two elements of the set, the result, or basically the answer to that addition, is also an element of the set. And so on your exam, I will ask you, as well as on your homework, I will ask you, is this set closed under addition, meaning it's closed under the operation of addition? And what that means is you can add any two numbers in the set, and the answer is also in the set. And so if we look at our first example, and I ask you to determine if this set is closed under addition, what you would need to consider is, if I added any two numbers in this set, would the answer also be in this set? And we can see that this set contains all of the even natural numbers. It goes on infinitely, carrying on the natural numbers. And so if I just begin adding numbers in this set, 2 plus 4 is 6. That answers in this set. 2 plus 6 is 8. That answers in this set. 4 plus 6 is 10, which would also be in the set. 6 plus 8 is 14, which would also be in the set, because it's all even numbers. And what you can begin to recognize is that if you add any two even numbers, the answer to that is also an even number. So the answer to any addition problem in this set would be included in this set. And so we would say, as an answer to this, yes, this is closed under addition, because it's specifically closed under the operation of addition, not the other operations, and so we do have to be specific with that. We're going to do the same thing on number 2. So if I add 0, and you also can add the element to itself. So if I add, for example, 0 plus 0, I get 0. 0 plus 1 would be 1. But then I also have to consider 1 plus 1, which is 2. You have to consider adding any two elements of the set, even the element to itself, that has to be considered. And so when I ask myself, are all of the answers to these addition problems in the set, I can quickly see that 2 is not an element of the set. And I would say, no, this is not closed under the operation of addition. So that's just something we want to begin this lesson with. Now the next thing that we're going to go into is just looking at some different models of addition, very basic ones, the models of sets and number lines. And so this is something you would do at a very early age, whereas in sets we would actually give them objects to use as far as to add. It could be as easy as, add 3 teddy bears to 2 teddy bears. add, 3 Legos to 2 Legos, add 3 hearts to 2 hearts. And when we model that by objects, excuse me, we're considering that set notation. We're also going to do that by a number line model. And what I want to now, so what I was saying is I want to pause and go into Lead Forward and actually look at some of the standards. And so I'm going to start with kindergarten because that's the earliest our TEKS go. And if we go into the addition and subtraction of whole numbers, in kindergarten, we're going to have our students add and subtract within 10. We're going to have them do that using objects and drawings, which is what we're about to go into. If you go over here and look at the supporting standards that support the readiness standards, we model the action of joining to represent addition and the action of separating to represent subtraction. We will explain the strategies used to solve problems involving addition and subtracting within 10 using spoken words, concrete and pictorial models, and number sentences, which is something we're about to look into. Now I want to go back into Lead Forward, and let me pull my screen over. That was kindergarten, and I just kind of want to show you this progression. So when we get into first grade, we can see here that our standards, we have a lot more standards as far as adding and subtracting whole numbers. In first grade, we're going to add and subtract within 20. But it gets, a little bit more complex in first grade. We're going to do it using concrete and pictorial models and number sentences, just like we did in kinder. But now we're going up to adding and subtracting within 20. In first grade is the first time where we bring in those fact families, and you can take a moment and go to Lead Forward on your own and really take a look into these supporting standards. And I'm going to bring in and explain to you the fact families later in this lesson, but you can see where we kind of get more specific on how we're going to teach that. By skip counting, we have, just more strategies. We bring in the fact families, and I just encourage you to take a second to go into Lead Forward and look at that. I want to go ahead and show the progression a little bit more into second grade. And so in second grade, if we look at our whole number operations, now suddenly in second grade, we are now adding and subtracting within 1,000. And this is where we start, carrying and borrowing for the subtracting as far as that. But this is another thing where I would encourage you to take a minute and go in and look and Lead Forward at the specific standards for adding and subtracting within second grade. When you're actually hired to be a teacher, the more knowledge you have on the standards and the being familiar with Lead Forward is just going to give you just an advantage over the other people who might interview who don't have that knowledge. So let's go back to the notes, and let's go back into just a very basic example of how we would model at a very early age, kindergarten, how to add 3 and 2 to get 5. We're going to do that using sets. And so in the classroom, I would recommend that you actually have objects. You could use base 10 blocks, chips, but we're going to take 1, 2, 3 objects in a set. And so here is my set. We're going to add another set that has 2 objects in it. And when we add those 2 sets together, we get a set with 1, 2, 3, 4, 5 objects in it. And this is where we can use those concrete tools to have the students have 3 of something, add 2 of the same thing to it to get 5 objects total. Now when we go to a number line, on a number line to model this type of problem, our number line would start with 0. Whereas we get into the higher grades and we bring in the integers, our number line might have negative numbers on it. But at this point, we're dealing with whole numbers, so my number line is going to start with 0. I'm just going to go ahead and number my number line, going 1, 2, 3, 4, 5, and I can go ahead and make it go to 6, even though the answer is going to be 5. And so to model this on a number line, if I could, in a classroom, it would be good to go ahead and maybe model this with different colors, which I can do here as well. So we're going to have our first jump on our number line is going to be 3 units long. So that's going to 3. After we get to 3, we're going to have another jump on our number line. That is 2 units long. And there's different ways that you can do this on the number line. You can do it as far as marking jumps, or you can use it, do it like I did, marking these arrows, the length here. And so I can see adding these 2 together, adding the 3 and the 2 together, lands me on the number 5. Now what some people will do as well, and I would accept this because it's just a different strategy, they will say I'm jumping 1, 2, 3, and I land on 3. After that, the problem tells me to jump 1, 2 more, and I'm going to land on 5. So regardless of how you look on this, you're modeling that adding 3 and 2 together gives us 5. Now the next thing we're going to go into is some different properties for addition, and this is some properties that are going to come up the rest of the semester anytime we do any type of addition, whether it's whole numbers or integers or excuse me, rational numbers. These properties are going to hold true. For the operation of addition only, these properties do not hold for subtraction, and so you have to be very careful if this is something that you put maybe on your note card, that you are very specific that this works specifically for addition. So for adding, we have our first property, which is called the commutative property. And what I want to do is I want to take a second and I'm going to actually go back to Lead Forward, and I'm going to go into the 3rd grade standards to show you that in 3rd grade, when we look at the addition and subtraction of whole numbers, give me just a second to zoom on this. Okay, so in 3rd grade, we are fluently, doing 1- and 2-step problems with addition. And what we do is based on place value strategies, properties, and operations, we look at the relationship between addition and subtraction. And when we get into multiplication, which is also going to hold true for addition and subtraction, I want you to recognize that these properties, commutative, associative, and distributive, which are specific also for multiplication, are going to come into play as well. That also is going to hold true for addition and subtraction. The specific strategies that we're looking at are going to work on addition, but I want to point out that this vocabulary is used as early as 3rd grade. So what the commutative property means, and again, you're also always able to go online and do some research on your own as far as just basic Google, Khan Academy, YouTube videos, etc. if you want more knowledge on this. But the commutative property specifically for addition just states that you can take an addition problem, and we're just going to keep it very basic. So let's say we have 2 plus 5. That's the same as 5 plus 2. So specifically for addition, the order of the problem can be reversed, and it results in the same answer, because you can see that both sides are going to give us 7. But that's only true for addition. It's not true for subtraction. So commutative changes the order of the problem, but it keeps the answer the same. The associative property changes the grouping of the numbers. And so let me give you just a numerical example of that. If I have 1 plus 2 in a group and I add 3 to that, that's going to result in the same answer as if I have 1 plus 2 plus 3 in a group. So changing where the parentheses is located can change the grouping of the numbers, but for specifically the operation of addition, that's not going to change the answer. So we know by order of operation that we always do parentheses first. So 1 plus 2 is going to give us 3 here plus 3, which is going to total 6. On the other side, by order of operations, we would do parentheses first to get 5. But when we add that to the 1 on the other side, it gives us 6. And so changing the grouping of the numbers can change what part of the problem you do first by order of operation. But if it's just the operation of addition, the answer will stay the same on both sides of the equation. And that's just changing the grouping of the numbers is called the associative property. The next property that we're going to look at is called the identity. And the identity specifically for addition is 0, because any number that you add to 0 is going to result in that same number. And so a very basic example of that is 0 plus anything. We can make our anything 5 is going to be 5. So what do we add to any number to get that number? 0, because 0 is the identity specifically for addition, not for other operations. Closure we've already talked about. If you have any two numbers, and you can add any two numbers within a set, and the answer is in the set, that is going to make the set closed. And we've already discussed that at the beginning of the notes. So the last example that I'm going to do for this first video is just looking at the problem and identifying what property is being used. You will have problems exactly like this on your exam. And so the first property I can see is the order is being changed, 12 plus 4 and 4 plus 12. And so the way that you will answer this for me is you will tell me that this is the commutative property for the operation of addition. And a lot of times I will get where people just put commutative property and they don't tell me that it's specifically for addition. And so you have to be specific with what operation you're working with. So I need you to tell me that it is the commutative property for the operation of addition. You have to put for addition, because these properties can also hold true for multiplication, and that's why I need you to be specific. On the next problem, a lot of people would miss part B because they're noticing parentheses, but what happens on part B is that the grouping of the numbers doesn't change. What changes here is the order of this first parentheses. What is in the parentheses specifically does not change. And so a lot of people here would tell me that this is the associative property, when actually, again, this is the commutative property. For addition specifically. So just be careful. Not every time you see parentheses in problems will, mean that it's the associative property. Now, when I look at my next part C, I kind of have to look at it in detail, and I have to recognize, what is in the parentheses did change, because this is 2 plus 4 and this is 2 plus 2. So the grouping of the numbers did change. But I also recognize that the order of the numbers changed as well. And so when I look at this problem, the properties that are involved here change the grouping of the numbers, but also the order of the numbers. And so this here is the commutative and associative property. For the operation of addition. And again, I apologize, my handwriting on this screen is not good at all, but you can hopefully at least read it to get the point. Now we'll go into the next video to address the next part of our addition. So if you'll go ahead and just move on to that.